Yep. Hello friends, how are you? In previous lecture, we have already discussed regarding to ideal solutions and non-ideal solutions. Based on ideal solutions and non-ideal solutions, there is another topic which is called azeotropic solutions, or we can say the azeotropes. If you have a clear concept of ideal and non-ideal solution, then you can easily understand the concept of azeotropes or azeotropic solution. So, in board's exam, the question is asked like this, and the question is define azeotropes and explain different types of azeotropes with example. So dear friends, already we know when there is a mixture of 2 or 3 liquids, so that mixture of liquid we can separate out by using fractional distillation. As you know, the fractional distillation of petroleum, fractional distillation of mixture of 2 liquids. One liquid first separate out having lower boiling point, then another liquid is separate out, then third liquid is separate out. But in chemistry, some mixtures are there of 2 liquids, majority binary solutions, which cannot be separate out by using fractional distillation. So these type of mixtures are called azeotrope mixtures or azeotropes. So the concept is like this: many binary solutions at definite composition behaves like pure liquid. So many binary solutions, they are not behaves like a solution, but they behaves like a pure liquid. And as they behaves like a pure liquid, so we cannot separate out them by fractional distillation, because their vapor have same composition of 2 components, same composition of 2 components as in liquid mixture, or we can say binary solution. As they are present, so see here, many binary solutions, their definite composition, they behaves like a pure liquid, because their vapor pressure and their vapor and their liquid state contain the same composition. The composition of this type of solutions is called azeotrope composition, and these types of solutions are called azeotropes or called azeotropic mixture. Any word you can use. See, this composition never separate out by using simple distillation method. So let us discuss in detail. Suppose in one container there are two components and it is binary mixture. See, this is a binary mixture. In this A plus D, this is called binary solution, and this one is the azeotrope. This one is the azeotrope, and the boiling point of this azeotrope is suppose T Kelvin. So at T Kelvin, this one is the vapor state. At its boiling point, this mixture is converted into vapor state. This one is the A plus D liquid, and this vapor also contain A plus B gas. A plus B liquid, A plus B gas. Now observe this. Many binary solution at definite composition, one is solute and one is solvent, binary solution at definite composition behaves like a pure liquid. This behaves like a pure liquid, not behaves like a solution. Because when this type of mixture boils at its boiling point, then the component present in a liquid state, see, the same composition of two components in their vapor and the same component of A plus B in a vapor phase. Okay. So this type of called azeotrope or azeotropic mixture. Okay. Suppose A plus B is not azeotropic mixture, then A and B can be separated out by fractional distillation. Suppose A, I repeat again, pay your attention here. Suppose A and B, which are in a mixture, which means which are in a solution, if they are not azeotrope, then A and B can be separated out by fractional distillation. But if A and B is azeotrope, then cannot be separated out by fractional distillation. So write down these things. So let us discuss the next one. Azeotropes generally two types. So let us just discuss regarding two types azeotrope mixtures. Azeotropes are two types. Type number one, that one is the minimum boiling point azeotropes, and second one is the maximum boiling point azeotropes. So So before discussing the two types of azeotropes, let us first discuss the definition of azeotrope. Definition of azeotrope. The mixture. After define the azeotrope, we will discuss the types of the azeotropes, minimum boiling point azeotropes and maximum boiling point azeotropes. The mixture of liquids which boils at constant. A mixture of liquids which boils at, this mixture of liquids makes binary solution and which is not separated out by fractional distillation. The mixture of liquids which boils at constant temperature and possess same composition in its vapor state as well as in liquid state. The mixture of liquids which boils at constant temperature and possess the same composition in its vapor state as well as in a liquid state is called azeotrope. It is also called constant boiling point. It is also called constant boiling point binary solution, because this solution throughout boils at constant temperature. Boils at constant temperature. Another important thing is azeotropes cannot be separated out by fractional, cannot be separated out by fractional distillation. This thing is important. What is the difference between simple binary solution and azeotropes? So one point is most important. Simple binary solution can be separated out by using simple distillation, fractional distillation, distillation under reduced pressure. So many methods already we have studied in 11th standard during the purification of organic compound discussion. But here azeotrope, that one cannot be separated out by fractional distillation. They remain as it is. If you boil it, then both boils together. Okay. So after the discussion of perfect definition of azeotrope, let us discuss the first minimum boiling point azeotrope. Okay. Minimum boiling point azeotrope. So see, the first one is a minimum boiling point azeotrope. So that can be explained. The azeotrope which shows large positive deviation, large positive deviation from ideal behavior is called minimum boiling point. Minimum boiling point azeotrope. So see, you know already what is azeotrope. So the azeotrope which shows large positive deviation from ideal behavior. Ideal behavior you know very well. Either positive deviation from Raoult's law or negative deviation from Raoult's law. This is the positive deviation from Raoult's law. It means the vapor pressure of this azeotrope is more than expected. Okay, the vapor pressure of this azeotrope is more than expected and boiling point is minimum. Boiling point is minimum. This boils at minimum boiling point. What does it mean, the minimum boiling point? The boiling point of this type of azeotrope is lower than either of the components. Either of the components. See, this is the minimum boiling point. Let us discuss this minimum boiling point azeotrope with one example. For example, preparation or manufacturing of alcohol. Manufacturing of alcohol by fermentation process of sugar gives azeotropic mixture. My friends, when we prepare alcohol by the fermentation of sugarcane or molasses or from sugarcane juice, and this alcohol is obtained is not a pure alcohol, it is an azeotropic mixture, or you can say the azeotrope, and that is the minimum boiling point azeotrope. This is obtained 95% by volume alcohol. Write down this thing. See, I am going to remove this concept to explain this. See, manufacturing of alcohol by fermentation process of sugar gives azeotropic mixture, and that is not a pure alcohol. That alcohol is obtained 95% by volume alcohol. What is the meaning of 95% of alcohol? It means 95% ethanol C2H5OH plus 5% water. And this concept is asked in competitive exam also. Which of the following is the azeotropic mixture? In a state board exam also asked. In a different local level exams also asked. In NEET exam also asked. In JEE exam also asked. So many azeotropes are there. Among them, this one is a well-known azeotrope according to the NCERT book. 95% ethanol plus 5% water. This one is the minimum boiling point of azeotrope. See, boiling point of ethanol, boiling point of C2H5OH is 351.3 Kelvin. The boiling point of water is 373 Kelvin. Now see the boiling point of azeotrope. The boiling point of azeotrope is 351.1 Kelvin. Now read this topic. The boiling point of this type azeotrope is lower than either of the components. See here, the boiling point of ethanol is 351.3 Kelvin. The boiling point of water is 373 Kelvin. But the boiling point of azeotrope is less than the boiling point of ethanol. This boiling point is also less than the boiling point of water. Okay, see, there is a less difference, but difference is there. 351.3 here, 351.1, 373, 351. And compare with this topic, the boiling point of this azeotrope, the boiling point of first component, boiling point of second component, and the boiling point of azeotrope is always lower. So, it is called minimum boiling point azeotrope. So, one question arises, we can prepare pure alcohol? Yes. My friends, written everything. Okay, write down. And let us discuss when from this type of azeotropes we can prepare pure component. One costly method is there, so alcohols are available in market very costly. Pure alcohol from this type of azeotropes, pure alcohol is obtained by using membrane technology. That is very costly one, which is very costly. So this type of another 2 or 3 solutions are there in chemistry, which shows this type of minimum boiling point azeotrope. And remember my friend, when there is this mixture is there during the fermentation of the sugar, this never be separated out by fractional distillation. Whenever this mixture is boiled, then always in vapor 95% alcohol and 5% water is present. By any method except this membrane technology, these two components cannot be separated out. So this is called minimum boiling point azeotrope. Now let us discuss the second one. That one is the maximum boiling point azeotrope. Second one is the maximum boiling point. Maximum boiling point azeotrope. So see, the azeotrope which shows large negative deviation from ideal behavior. Large negative deviation from ideal behavior is called maximum boiling point azeotrope. So that one shows large positive deviation, this one shows large negative deviation. It means the vapor pressure of azeotrope is less than expected. See, if you have a clear concept of ideal and non-ideal solution, then it will be very easy for you. The vapor pressure of this azeotrope is less than expected. Another thing, the boiling point of this type of azeotrope, the boiling point of this type of azeotrope is more than either of components. See here, less than the both component, here opposite concept is there, more than the both component. Let us discuss by taking one example. This is a 68% weight by weight HNO3 solution. Good example. 68% weight by weight HNO3 solution. It means 68% HNO3 plus 32% water. So let us discuss how the boiling point is there. See here, the boiling point of HNO3 is near about 359 Kelvin. The boiling point of water is 373 Kelvin, and the boiling point of azeotrope, and that one is the boiling point of azeotrope is the 383 Kelvin. Now observe here, the boiling point of HNO3 component number 1 is a 359 Kelvin, so here is the higher boiling point 383 Kelvin. The boiling point of water is here 373 Kelvin, so boiling point of azeotrope is 383 Kelvin. Now see here, the boiling point of this type of azeotrope is more than either of the component. This one is more than this both component. And I repeat again, whenever this mixture is prepared either in a laboratory or naturally obtained, then this never be separated out by fractional distillation. Remember, otherwise the simple mixtures of two liquid can be separated out by fractional distillation. Sometimes they can be separated out by simple distillation. Sometimes for delicate liquid we are using the distillation under reduced pressure. So my friends, based on ideal solution, non-ideal solutions, positive deviation of solutions, negative deviations of solutions, based on this we discuss this topic. That one is the azeotropes. First I explain you. Second one, that one is the types of azeotrope with one example, definition of azeotrope. Two types of azeotropes are there. One is the minimum boiling point azeotrope. Second one is the maximum boiling point azeotrope. I hope that you have written all these things. And last, some important point is, if you revise the topic of ideal solutions and non-ideal solutions, okay, then one thing is clear by this azeotrope and non-azeotrope, then that is, see, ideal solutions never form azeotropes. Most important, whenever there is a solution is ideal. See, in a previous video conference I have given you the 5 mixtures of ideal solutions. So sometimes the question asks which of the following cannot form azeotrope. Then the mixture which is from the ideal solution, they never form azeotropes. Remember, those solutions which are non-ideal solutions can form azeotropes. And after deciding either the solution is ideal or non-ideal, if it is a non-ideal solution, then you can say yes, it is from azeotrope. And then you have to decide which one is the minimum boiling point azeotrope and which one is the maximum boiling point azeotrope. Okay friends, in next lecture, if it is possible, then I will discuss with you about the colligative properties of solution. Based on this, here this is the application of ideal and non-ideal solution. Thank you friends, thank you very much and have a good day.